All right, guys. This is Tommy again, here to talk to you about simple AWS networking because we had a lot of questions about that recently. So here we go. Clouds, subnets, zones, oh my. So there's a lot of really good things that we want to talk about with this, specifically VPCs, subnets, availability zones, regions, how all these things tie together, because almost everything else in Amazon relies on these basic building blocks that all come down to like the Amazon networking stack. Okay, so we're going to jump right into one of the most important things, which is availability zones. Oop, too far. Regions and availability zones. Okay, so a region is a distinct and separate geographical area, and these are, I forget how many there are now. There's probably around like more than 10, less than 20. But these are things like US East 1, US West 2, AP Southeast 1, Virginia, Oregon, Singapore, all these things. Those are all regions. All right. Now, all AWS resources exist inside regions at the top level, except for the only things that do not exist specifically in a region are the identity access control, identity access IAM. All the IAM stuff, all of that stuff is global. It's everywhere. And there's a handful of other global things like DNS with the AWS Route 53, all the DNS service stuff. That's all global because DNS is global. And then there is a special setting with like S3 buckets where you can do global buckets and stuff like that. There's a small handful of things that go beyond regions, but 99% of everything else in Amazon is all constrained to a region. So at My Educator, for instance, we deploy all of our stuff to US West 2, all right, which is in Oregon. US West 1 is in California. There's US Central, all these things. Now, a region is actually several availability zones. An availability zone is an isolated location, okay? A region always has at least 2 availability zones. It's kind of just a rule with Amazon, because an availability zone is essentially, it's its own isolated data center. Okay, so a region isn't just one data center. It's normally several data centers. I think the common is to have 3 availability zones. Sometimes some places have 2, and I think Amazon is almost always working to build them up to having 3 in every region. But an availability zone has its own identifier, and it's normally just whatever the name of the region is, plus a letter. So US West 2A, B, and then C. They don't have any other fancy names other than that. It's just, ABC, and those will be, so down here you see in a couple of the pictures we have like, one data center is essentially, you can think of that as an availability zone, because the idea is if one availability center got nuked or something like that, you wouldn't have to worry if you had things spread across to another availability zone. Okay, so you can see in this graphic down here. Now, this ties in very importantly into virtual private clouds, which are a little bit of a newer concept in AWS over the last, I want to say 5 years. I forget when they first really did it, but they're very important because now this is the default, and it's a very good default. The VPC, the virtual private cloud, is a virtual network that is dedicated to just your AWS account, and not like your user account. We're talking about our full company My Educator account. Okay? There is one account tied to one. It's really, you can think of it as an AWS account, as in one billing account. Okay, so in that AWS account, it can have many VPCs. There will always be Amazon creates a default VPC for you. Has that capability, and if you ever create if you create EC2 instance servers, they will always go into VPCs. If you don't specify which VPC to go to, it will go to the default. Okay, but it used to be that we could just create EC2 servers just in the account, and they weren't attached to any kind of private virtual network or anything like that. They were just almost like spinning up a DigitalOcean server. You just spin it up and it's just there attached to the internet. Good job. But Amazon has since then moved away from that, and now by default it will create you a little virtual private cloud. And if you don't want to worry about it, you don't really have to. It'll just you can just create EC2 instances. They'll automatically go to the default network, and the default network is already set up to allow traffic in and out of the the internet. Okay, so a VPC is logically isolated, and it has a specific IP address range. This IP address range is a private IP address, which is important because your virtual private clouds will not clash with other AWS accounts. Okay, so anything that we create in MyEducator, we often will be a VPC will have, like down here, 10.0.0.0 /16. That's a pretty common and good VPC network address to use, and it's very common. A ton of other people could use it, but it doesn't matter because they're isolated into an AWS account. We just have to make sure we don't ever clash with that. We're not allowed to ever make another VPC in the same region that has that same network. Actually, I don't even know if Amazon does protect you against that. Who cares? But anyway, you don't want to do it. Even if they do let you do it, you wouldn't want to. Okay, so don't. But you'll also see in this graphic, a VPC exists in one region, and a VPC spans all the availability zones. Okay, so in this one, A, B, and C. Most regions have 3 availability zones, A, B, C. Okay, with that ABC, Amazon handles all the routing and stuff like that between them. It has defaults to handle the routing. It does create route tables, which by default just will keep everything internal. Except for the default VPC also has things called gateways, which will handle internet traffic. I'll get to that in the next section here. But the important thing to remember here is that a VPC is really just a virtual network that we decide what the network address is, and then we can slice that up and we can into subnetworks and determine how we want to allow things to talk. Whether it's how we want things to network and talk within our infrastructure, and also how we want traffic to come from the outside in. So this helps a lot with security when you do it right. So that brings us right in here into subnets. Now, for right now, ignore this kind of tricky graphic for a minute, and let's just talk about when you create a VPC, you're going to add one or more subnets in each availability zone. Okay, a subnet has to live entirely in a single availability zone because it doesn't make sense in Amazon's network routing to have subnets that would go outside of like a physical location. So a subnet lives basically in one AZ or one data center, and while your VPC will go all of the availability zones, your subnets are isolated to one. You could have a lot of subnets in the same VPC in one availability zone, but that is a constraint that's important. In general, you'll want at least to divide your VPC into one subnet per availability zone. That's what the default VPCs will do. They'll just divide the default network into 3 pretty much equal subnets that are all publicly available subnets. Anything that goes into them, any server that goes into them will get a public IP address and be routable from the internet. That's the Amazon default. A good practice that we like to do is to actually create 2 subnets for every availability zone, a private and a public. And the idea is that the public subnet, it is connected to the internet via these internet gateways, and traffic can route in from the outside and be reachable, and services inside these public subnets can be reachable. Okay, but the private subnet, it can't be reached directly from the internet. It can be reached within subnets because your subnets within your VPC, they can all talk to each other because, the route tables that we set up, I kind of been skipping over this whole part about setting up the routing tables, but it's normally not too big a deal. But it's very normal to have all your traffic, just keep all the traffic local, but public subnets are allowed to talk to the internet through an internet gateway, and private subnets, they receive traffic from within the public. And what that means you can do is you could stick, for instance, a load balancer into a public subnet, but all of the EC2 servers where you're running your application, like all the servers where we're running our Django app or Rails app or whatever, they're all running in the private subnet, and the database is running in the private subnet. And what that means is nobody from the outside can punch in an IP address and try to reach any of those back-end servers. They can only talk to the load balancer. So it's kind of nice. It gives us that extra layer of protection. All right, so there's a lot that goes into network dividing with subnets, which I'm not going to be able to cover. So with this little diagram over here, it's pretty similar from the last one. Okay, VPC, availability zones, yada, yada, yada. Now we go and we fit in one subnet to each of these, subnet 1, 2, 3. Okay, and you can see their addresses are subnet 1. The VPC address is 10.0.0.10.0.0.0/16. Okay, subnet 1. Subnets always have to be smaller than than their parent, than their main network. So 10.0.0.0.20/24, 1.0/24, 2.0/24. These are all smaller. And now these little boxes are example EC2 instances. Okay, we launch these A and B into EC2 instance into the subnet 1. It gets a private IP address for that subnet. Each of them do, which comes from the subnets network. Same with the other ones there. And this stuff is showing that you have control over how you want to route traffic in. To communicate on the internet, a VPC has to have an internet gateway device. Okay, that is what connects, that to the outside world. The internet gateway can be, the route tables can be set to allow, an EC2 instance, a server, to send all of its outbound traffic directly to the internet gateway, or for the thing with an internet gateway is that flows both ways. If traffic that goes out of it traffic can come back into it. So if an internet gateway is directly connected to a subnet, it will, be able to, people will be able to talk back in when you set it up that way, which you want that to happen, but you want it to happen in a controlled way. So I'm going to kind of gloss over a little bit internet gateway and NAT gateway because I'm going to show some demonstrations in a few minutes about how they work. But the important thing to know is that an internet gateway you'll want in your VPC, but you'll only want it to be routing incoming traffic to your public subnets, and you don't want it to be routing incoming traffic directly to your private subnets. Okay, going outwards, everything does eventually have to go out your internet gateway, but normally what we want to do is, your public stuff, they can talk directly to, their outbound traffic can go directly to the internet gateway, but in a private subnet, we would instead set up some NAT gateway devices that would then go out from there. So I'm trying to remember if I think a NAT gateway doesn't go directly to the internet. I think a NAT gateway has to go, NAT gateway to internet gateway and then out, but I'd have to double check that one. But the important thing there being a subnet is breaking apart a VPC into smaller networks, one or more smaller networks, and they all live in a single availability zone. Now, this brings us to security groups because it's a very common sticking point. Is a security group is really just the Amazon way of explaining a virtual firewall. Okay, And security groups are often attached directly to EC2 servers, just the servers that we spin up. You can attach several security groups to one instance. Or security groups are actually used in a bunch of places because you can assign security groups to all kinds of different, AWS resources. Which, one of the reasons why VPCs and subnets are so important is that there are many Amazon services and resources that you will say, oh, I want to create an Amazon managed relational database service, the Amazon RDS, where it will create and manage a MySQL or Postgres database for you. But for your applications to be able to connect to it, you need to tell Amazon, you need to tell RDS, here are the subnets I need you to connect to. I'm going to go back here. Here are the subnets I need you to connect to. Every subnet has a unique ID. RDS, you need to connect to these subnets so that my things can talk to you. All right, so there's actually quite a few services where that you need to do that sort of configuration. When we set up Kubernetes in our new VPC, this was another thing, is that Kubernetes had to know what subnets are available so it could, it could be available to route traffic and do stuff inside of them. So security groups are virtual firewalls, and as these virtual firewalls, you can define rules that control the traffic coming in to a resource and the traffic going out from a resource. Most of the time, a security group is used to control the traffic coming in, because a lot of times we assume that traffic going out is probably fine, and it's not traffic like returning. It's connections initiated from the inside going out. It's about where the connection is initiated from. Because even when data comes in, it's, the virtual firewall will allow the response back. What the virtual firewall is caring about is who is trying to initiate a connection. All right, and that's what we're controlling. So it cares about the ingress and the out and the egress. Okay, all VPCs when they get created, they have a single default security group, and then you can create a ton more. These normally tend to explode in number because there's all kinds of different things that you may need to do. By default, this is a pretty good little example here. The default is for traffic connections coming in, allow any traffic to any port if the sender also has this same security group. So that's kind of a cool thing, because security groups when they do their traffic filtering, they can filter on a whole different set of things. They can filter traffic based on the protocol that it's using, based on the address it's coming from or the address it's going to, the port it's coming from, the port it's going to, same thing. Or it can even do it it can tell, hey, this is a connection from inside this VPC from something that has this security group. So that's kind of cool, is the security groups can be set up to talk to each other, where you can just say, oh yeah, this is kind of cool for if you give a security group, you name a security group, the database security group, and then you make another security group called the web application, the web app security group. You could put in as a rule, database only allow ingress connections coming in from a source that has the security group web app attached to it. So only servers or other whatever resource we attach to it, only servers that have the web app security group are allowed to talk to that database thing. So that is the little trick that the default one uses, is by default, if you just give everything in your VPC the same default security group, they're all allowed to talk to each other for ingress. And then for egress, the default security rule just says, any outgoing traffic is allowed. Okay, and you do normally tend to see that pretty commonly. There's a lot more constraining of the incoming connections, not a lot of constraining of outgoing connections. Although some people do definitely use it.